So we have arithmetic logical unit here. This is an arithmetic logic unit, short for ALU. This is the circuit for it. So we have three questions here. First one is label the missing quantities in the box. Okay. So what we have here is we have addition being performed in this box here. That's where addition goes on. So the output from these are exclusive OR gates, and we'll call this one A, and this one B. So basically, a stream of numbers come into um, these logic units. So for example, we'll have a number like 00110000. This will be A, and that'll be from left to right. The numbers that will be represented here, 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 and here, and here, and here, and here. And the same goes for B at these points. Whatever number you choose that to be in binary. Alright. So now then we have this one here. Now if you pick 0, it's addition, 1 is subtraction. Right, so like if you're doing addition between binary numbers like 0, 1, which is 1, 0, 1, right? 1, 1, 1 plus 1 in binary, it's a 0 left over, carry over 1, 1, 0, that's 2 in binary, right? This is 2. And then binary, this is 1 and 1, right, which is equal to 2. Right, that's binary addition. So you can't really perform subtraction in binary. So for this unit, when you plug in a 1 into um, this this here, we'll call it F, right? Down here it's F. Um, you'll get certain functions like in this graph here, but for this specifically this circuit, it's 1, which is subtraction, right? Going in, right? So we have boxes, and from the information we're given, we have to predict what these boxes are. So we have a 0 here, right? And this 1 here, right, is connected. It goes in here first, right? But it's also supplying all these exclusive NOR gates up top, as you can see, um, which are all 1. So for this first one, we have 1 going in here, right? From this area. And then we have a 0. We have a 0 here and a 1 here, so that's going to output a 1. So 1 plus the 1 here is going to give us a 0 and a carryover of 1. Alright, now let's look at the top ones in this next one. Right here. Got a 1, 0, 1, and another 1. So 1 plus 1 plus 1. 1 plus 1 is a 1, as a 0 carryover, right? And then you got to plus another 1, which is 1. So you have carry over the 1, and the remainder is a 1. Alright, so you carry over the 1. So how do we get an output of 0? So there's a 0 here, but we need another 1 to get that 1 plus 1 remainder 0. right, with that carryover. So since this is a 1 here, we need another one. This will be a 0. So 0 plus, or 1 plus 1 is 0. Carry over another 1. 1, 1. Alright, so this exclusive NOR is going to output is 0. Also 1, 1, 1. 1 plus 1 is 0. Carry over a 1. Um, so the output has to be a 0. How do we get a 0? So 1 plus 1 gives us that 0, so we have a 1 here. We need to make this exclusive OR a 0 then, so um, the output is 0, we'll make them both the same. 1, 1 for exclusive OR gives us 0. 1 plus 1 is 0, carry over another 1. Alright, for the next one we got 0, 0, 1. Exclusive OR output's a 1. Then we got that carryover as a 1. So that's a 0, carryover 1. 0, 0, 1. No carryover. Alright, then we got 0, 1. That's a 1. The output's a 0, so this has to be a 1. So carry over a 1. So that fills in the quantities for the box. So what is the operation being performed? Well, I know since this is a 1, it's subtraction. When you put in a 1, it makes the subtraction. So subtraction. So what is their overflow? To find overflow, you compare the final carry out, right, and your C out, and then exclusive OR gate, right? So if there's an output of a 1, there is carry out. If it's 0, there's no overflow. I mean, if it's a 1, there's overflow. If it's 0, there's no overflow. So we have a 1 and a 0. So there's overflow. And overflow. 1, 0, overflow. 1, 0 outputs a 1. So that's overflow. That's number 1. So for number 2, we have arithmetic logic unit. This is arithmetic logical unit with like functions. This one performs like basic functions. This whole circuit uh, performs functions, is what it does. Okay, so upon further discovery, I figured out what this whole circuit is. This is not the same as this circuit up here. Two different things, right? This is literally just an adder. That is all that is. Whatever number comes into there is just adding them, right? This this is literally just a circuit that does these functions. That's all it is, right? So the this what this first part is doing is basically getting the 2's complement of that. That's all it's doing. Or the 1's complement. So how do you get S? S is basically um, the 2 to 1 mux after B passes through it plus A. A is 0, 0, 1, 1 plus 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1. That's what S is. Right. And there's no carry out. But the 0110 is what's being carried. These are your carry numbers. What's the value of y? Well, like I said, 110 is f2, f1, f0. f1 and f0 are down here. So it's 1, 0. And these correspond to 1, 1, 1, 0, 0, 1, 0, 0 in binary, right? So 1, 0 is here. So 2 is S, which is Y, which is 1, 1, 1, 0. Done. What do you wish, Ben?
I wish there was like someone to talk to about when it came to like financial aid stuff.